Okay, Jay, let's proceed ahead with your mock interview for Bhavatomic Research Center, and this subject which we are proceeding is fluid mechanics, right?
Okay, sir.
Good. So let's start with the fluid properties.
Okay, sir.
Can you tell me the most important fluid properties and why they are most important?
Okay, sir. There are various fluid properties which can be broadly classified into intensive properties and extensive properties. Some of the important properties are pressure, temperature, density, and there are other properties like internal energy, specific internal energies, entropy.
Okay.
So these are some of the important properties of the fluid.
Okay, so can you tell me something about viscosity?
Yes, sir. Viscosity is a property of a fluid due to which resists in the flow.
Okay, if I give you water,
Yes, sir.
how the viscosity of water changes with rise in temperature?
Actually, sir, for fluids, viscosity is inversely proportional to temperature. And as temperature increases, sorry, sir, as temperature increases, the viscosity of the fluid decreases, sir.
So suppose I take water in a beaker.
Yes, sir.
I give you water in the beaker at room temperature.
Okay, sir.
And then you start raising its temperature.
Yes, sir.
Now draw the graph of its viscosity, dynamic viscosity versus temperature. How shall it be?
Temperature, sir. Sir, I am not able to say.
You know what is dynamic viscosity?
Sir.
So as the temperature increases, what happens to dynamic viscosity?
Sir, dynamic or kinematic, sir?
Dynamic viscosity.
So dynamic viscosity is mu, and for liquids, as temperature increases, mu decreases.
So can't you draw the diagram?
Sir, is it something? Sir?
Up to what temperature it will decrease?
So for water, it is 0 degrees Celsius, it will turn into solid. Properties change.
Water is at the room temperature and I am increasing its temperature. So up to what temperature it will decrease the viscosity? Because at 100 degrees centigrade, water starts boiling.
Yes, sir.
The moment water starts boiling, temperature becomes constant.
Yes, sir.
I want you to tell me what happens to viscosity when temperature becomes constant. 100 degrees centigrade.
Viscosity also remains constant.
So what kind of graph will you get? Can you put some kind of values and
okay, sir. Sir.
Okay. Now do one thing.
Sir,
Instead of water, take salt water and tell me how the graph will be different.
some news actually depend on cohesive force and intermolecular attraction.
Yes.
For salt solutions have
How the water is different from salt water? What does salt water do? What does salt do in water when you add it? Increases, decreases viscosity or what?
so when salt is added, the density of the liquid increases.
Mhm. What about viscosity?
Viscosity, sir. Sure, sir.
Let me give you an idea. It will increase its viscosity when salt water is added.
Okay, sir.
Can you superimpose the same graph now on salt water? Let's take salt water and on the same graph plot the graph for salt water. Knowing that at the room temperature viscosity of salt water is more than that of fresh water or pure water. Try to superimpose the graph.
Sir.
You tell me, when you boil a salt water and when you boil a fresh water, what is the difference?
There may be a change in the boiling points. And
Let me ask you, lake water and river water.
yes, sir.
Which of the water has higher specific gravity?
Specific gravity, rho by rho, just lake water, sir.
Why?
Because it usually contains various type of salts, so its density is high.
Why? Why lake water has more salt? And sea water is the saltiest.
Yes, sir.
Any reason for that?
Sir.
So, anyhow, any idea about viscosity of sea water is more or viscosity of water in river is more? Okay, you must have done this experiment in physics in school. Salt water, you boil
Yes,
it.
sir.
What happens? Water evaporates.
Water evaporates and salt it gets salt
Salt? Salt also evaporates or remains in the water.
remains in the water.
So, as the water boils,
Yes, sir.
the remaining water
Yes, sir.
Keeps on becoming more salty.
Yes, sir.
What happens to its viscosity?
Its density increases, viscosity also increases, sir.
Can you plot the graph now? As we are boiling the water, water is evaporating. What is happening to the viscosity of the water which is remaining in the beaker now? Do you think that is the steepness you will get? That much steep rise? It can't be that rise.
Gradually,
It cannot be that much of rise. Okay, if I want to reduce the specific gravity of the water,
okay, sir.
the way I added salt, its viscosity increased.
Yes, sir.
If I want to decrease its viscosity, what should I do?
Add some more water.
Add some,
Water.
but the same water has. I'm taking the fresh water. I'm not taking the
Okay.
salt water.
Okay.
I'm taking the fresh water. Now I want to decrease its viscosity.
Sir.
What should I do?
Increase the temperature.
What else? You added salt, you increase the viscosity. What you should add to decrease the viscosity?
The same amount of water, but not adding water. Any liquid.
Have you studied the concept of hard water? Water hardness
Yes, sir. I have
in the school.
during the school time, sir.
Then what he used to do?
But I cannot recall, sir.
What if you add detergent in water? Its viscosity will increase or decrease?
Viscosity increase, sir.
Viscosity will increase surely. So if viscosity increases, what happens to intermolecular attraction?
Intermolecular attraction increases.
And what is intermolecular attraction? Cohesion or adhesion?
Cohesion, sir.
Cohesion. And cohesion is surface tension.
Yes, sir.
That means adding detergent increases surface tension. Is that what you're saying?
No, sir. Surface tension decreases while adding. Detergent.
So when you add detergent, viscosity increases or decreases?
Sir, viscosity and surface tension are different properties.
But they are somewhere related also, right? Because they are fluid properties.
Okay.
They are related at intermolecular attraction force. Surface tension is intermolecular cohesion.
Yes, sir.
And so is viscosity.
Yes, sir.
So if intermolecular attraction increases, surface tension increases.
Okay.
Right or not?
Yes, sir.
Now tell me, when we add detergent, what happens to viscosity of water?
Viscosity decreases, sir.
But when we add salt, what happens to the surface tension of water?
Surface tension increases.
And viscosity?
Also increases.
Are you sure surface tension will increase when we add salt?
Sir, viscosity is increasing, so surface tension
Hmm.
also.
So why it happens that when add salt, surface tension or viscosity increase, when we add detergent, it decreases? Why it is so?
Correct. Since surface tension is proportional to cohesive force, when adding detergent, their cohesive force is decreasing.
So what detergent must be doing to intermolecular attraction or something? It must be decreasing intermolecular attraction.
Yes, sir.
How?
By occupying the space between the molecules.
Sorry.
By occupying the space between the molecules.
Hmm. Okay. You know what is the capillary effect, Jay?
Yes, sir. Yes, sir.
Hmm. You know the formula of capillary height, rise of height in capillary?
Yes, sir.
Hmm.
For H is equal to 4 sigma cos theta by rho
Can you
GD.
draw the graph between the height of capillary rise and surface tension? Hmm. Now let me ask you,
Yes, sir.
as the surface tension increases,
Sir.
water has more surface tension or mercury?
Mercury has more surface tension.
In which case, height rise is more, water or mercury?
For mercury, we are having capillary depression,
Hmm.
and for water, we are having a capillary rise.
So now think of, if surface tension of a fluid is more, do you think height of capillary rise will be more or less?
Sir, for that type of fluids that showing capillary rise, with H increases with sigma surface tension.
No, I could not get. My question is, if I give you two fluids, one with high surface tension, other with low surface tension,
Yes,
in
sir.
which fluid you will have more height rise?
So the height is proportional to surface tension. So the fluids with higher surface tension
Don't see
has.
the formula, just answer from common understanding.
Okay, sir.
Answer from common understanding how it goes. If I give a fluid with the high surface tension, rise will be more or less? See, surface tension is nothing but cohesion.
Yes, sir.
Cohesion is intermolecular attraction.
Yes, sir.
If surface tension is more, water molecule will not let molecules to go in the glass fluid.
Okay, sir.
Surface tension is more, that means height is less.
Yes, sir.
But why in your case it is coming proportional? What do you think?
Sir, I drew this from the equation point of view, sir.
Where you are wrong? What mistake you have done? You assume certain things constant which you cannot assume actually.
Sir.
When you change one property of the fluid, you cannot assume other property to remain constant.
Okay, sir.
That is the one mistake you did. Another is there are other factors also which are changing. Can you tell me what happens to the density of the fluid when surface tension increases? You have the example of water and mercury.
Yes, sir.
Density of mercury is 13.6 times that of water.
Yes, sir.
The surface tension is also very high. So as the surface tension increases, which is because of intermolecular attraction, density also increases.
Yes, sir.
So tell me what happens to angle of contact with increase in surface tension?
Of contact increases, sir.
Angle of contact increases, right?
Yes, sir.
Now, as the theta increases, what happens to cos theta?
Cos theta decreases, sir. Decreases.
Now put all these things together and draw the graph. As you increase surface tension, density also increases, cos theta decreases. Now tell me what happens to H with surface tension.
Sir, H also decreases, but I'm not sure about its slope, sir. Just
Certainly it will not increase.
yes,
Certainly
sir.
H will not increase with the increase in sigma. As the
Yes,
surface tension increases, height will not increase.
yes, sir.
Right?
So,
Can you extrapolate this graph further? Keep increasing the surface tension and extrapolate it further.
sir,
Yes. So what is the meaning of negative here?
capillary depression, sir.
Why it happens? At what point will it happen? When H becomes negative.
When cos theta is
Negative. At what value of theta?
at 190 degrees, sir.
When it crosses 90 degrees, right?
Yes, sir.
Done. Okay, Jai, let me give you feedback. How
Okay,
was
sir.
it?
Not as expected, sir.
Will you pass or will you fail?
I think I have to prepare more.
You will not pass. Don't get
Okay,
disheartened, but you will not pass with this
okay,
interview. And they will ask, this is a typical BARC interview. Typical.
okay, sir.
They'll keep on pulling you, where you yourself start feeling, oh, what an idiot I am.
Yes, sir.
How can I make such mistakes, right?
Yes, sir.
Very basic thing. They start with physics. They pull you down into physics. Slowly, give you sufficient time to think. And then you start making some kind of mistakes.
Yes,
You need to get that feel. The good thing is, maybe today's mock you fail, today's mock you don't qualify, but
yes, sir.
tomorrow's mock you may pass if you acquire that kind of temperament of answering questions. Start thinking.
Okay.
BARC interview is entirely different from all other interviews. This is the typical BARC interview, and some of the questions were actually asked in previous BARC interviews.
Okay, sir.
So, surface tension, viscosities, these are the things we study in all the books of fluid mechanics, right?
Yes.
And even physics in 11th, 12th class also. We put the things together. Water hardness we have studied in the physics in 11th
Yes.
class. When we do engineering, we don't study those concepts because engineering, the person who writes book, he assumes that we already have the knowledge of 11th physics.
Okay.
But we tend to forget that. My advice is like refer those concepts from 11th class also.
Okay.
Right? And there are certain things like when you are making a graph between H and sigma, don't forget that you cannot keep other factors constant. Maybe acceleration due to gravity or diameter you can take constant, but can you keep density and angle of contact constant? When we know that angle of contact actually depends upon surface tension, because angle of contact for high surface tension bodies like mercury is obtuse, whereas for water it is acute.
Yes.
So we cannot make those mistakes. We cannot assume irrational things in physics. We cannot assume that.
Okay.
This is how it goes in BRC. And that's the reason BRC is a beautiful interview.
Yes.
Right? They will take you to lake, to sea, to rivers, natural things, make force you to think more, right? Now keep doing that. Date has not come, right?
Yes, sir.
Date has not come.
I have booked my slot on 1st June.
1st June.
Yes, sir.
You have less time, prepare well.
Sir, what to refer to, sir? Because I cannot
can't
answer.
say what to refer. I really can't tell you what to refer because there is no book actually for this.
Okay.
It's all concepts. I have already told you 11th class physics also you see the concepts. Whatever you're studying, see the concept of fluid mechanics you have done in 11th class also.
Yes.
All I can tell you is that please see those concepts also, NCERT or something. Brush up your concepts of physics also.
Okay.
Sometimes they tend to ask you questions from there. And practice makes you perfect.
Okay.
You start thinking on those lines. Like I gave you today a concept that H and sigma, draw a graph between H and sigma. Next time when they give you this question, you will be very, very cautious that should I plot like this or should I consider the parameter? Agree or not? So
I agree,
mock you understood one concept that this is how it goes. Just add it up. So I'll say more mocks helps it.
Okay, sir.
Right?
Sir, when can I attend my next snap, sir?
No, it takes a lot of time actually. So you pop up and whenever I'm available, I'll provide you the time slot.
Okay,